Hi, today we're going to do section 5.1, which is theorems about perpendicular and angle bisectors. During this video, I'll ask you to put the video on pause so that you can go through some of the proofs and the practice problems. So one of the definitions that we have first is equidistant, and basically it's saying that two segments are equally distant from a given point. So we're talking about equality, not congruency. So AB is equal to BC. Please put the video on pause so that you can read through these two theorems. The first theorem is referred to as the perpendicular bisector theorem. It states that if a point is on the perpendicular bisector of a segment, that it is equidistant from the endpoints of the segment. So in this given diagram here, we have line XY is the perpendicular bisector of line segment AB. What the theorem states is that anywhere on this line, any point on this line will be equidistant from the endpoints. So here we have point X. It's equidistant from A and B, so we can make a statement AX is equal to XB. That would also be true of Y. We could say that YA is equal to YB if it's on the perpendicular bisector. So in this given information, this given problem here, we are given that XY is the perpendicular bisector of AB, and we want to prove that XA is equal to XB. So from the given information, if we know we have a perpendicular bisector, then we know we have perpendicular lines, so XY would be perpendicular to AB. Then therefore we have right angles by definition of perpendicular. So angle XYA and angle XYB are right angles, and they are congruent by right angle congruence theorem. If XY is the perpendicular bisector, then Y is a midpoint. And so then once we have Y as a midpoint, then we know that AY is congruent to YB. We could then say that XY is congruent to XY by reflexive property, which makes these two triangles congruent by SAS. If that's true, then XA is congruent to XB by CPCTC, and then that means that the segments are equal to one another. The converse of the perpendicular bisector theorem states that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So in this given problem, we have point X, which is part of line XY in this case. Point X is equidistant from A and B. In order to make the determination that XY is indeed the perpendicular bisector, we would have to make sure that it meets both conditions of a perpendicular bisector, that it's perpendicular to AB and that Y is the midpoint of AB. So based upon the given information, we can give line XY one condition. So if I said to you that XY is perpendicular to AB, then we know we have right angles. We know, since the given information, that XA is equal. That means that they are congruent to one another, and that XY is congruent to XY by reflexive property. That makes these two triangles congruent to one another by HL, which would mean then, therefore, that AY is congruent to YB, and that Y is therefore a midpoint. Therefore, XY is indeed a perpendicular bisector because it meets both conditions of being both perpendicular and intersecting AB at its midpoint. One of the things that you need to be careful about is to consider the fact that XY in this diagram doesn't necessarily have to be a perpendicular bisector. Remember, through any one given point, there are an infinite number of lines that can be drawn. So we need to make sure that we have a situation where we know that a line is indeed a perpendicular bisector. So you have a separate handout that has this information on it, and I noticed that a little bit is cut off on the video, so I'm going to read through it. This outline is going to be handy for you when you're doing your supplementals. So to prove that a line or a line segment is a perpendicular bisector of a given segment, you need to kind of set up and show that the following conditions are met. So here, if we are to prove that EM, line EM is the perpendicular bisector of GK, we must prove or state that 2 points on EM lie on the perpendicular bisector. Remember, any 2 points make a line. So we do this by proving the following, that E is on the perpendicular bisector of GK using the converse. So we would have to prove that EG is equal to EK. And then we would also have to prove that MG is equal to MK using the converse. If we have met both of those, then we can say line EM is the perpendicular bisector by the line postulate. And again, check your handout that I sent you on Google Classroom with respect to this. The definition of locus says it's a set of all points that satisfies a given condition. So the perpendicular bisector of a segment can be defined as a locus of points in a plane that are equidistant from the endpoints of the segments. There are an infinite number of points on that perpendicular bisector that's going to meet those conditions. So please put the video on pause and answer this example problem. So hopefully you see by the perpendicular bisector theorem that 3x squared minus 6 is going to equal 7x. You go ahead and solve that, and you're going to find that x is equal to 3, and then therefore tu and tv are equal to one another, and they're going to equal 21. So I don't have all of the steps written out for you here, but indeed x is equal to 3, and your answers are 21. Please go ahead and do example 2. So in example 2, based upon the given information, we know that these two triangles are congruent to one another. So G is on the perpendicular bisector. And so we know that point F would be a midpoint, and so that both DF and FE are going to equal 10.4. Remember that the distance between a point and a line is the length of the perpendicular segment from a point to a line. That's going to be important when we talk about the theorems relating to angle bisector. Please put the video on pause while you read through these two theorems. The first theorem that we are going to take a look at here is the angle bisector theorem. It says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So in this diagram, the diagram down here, the given information is that ray PC is the bisector of angle APB. And we are trying to prove that AC is equal to CB. Well, first of all, you see that there's nothing drawn here, so that's going to be one of our first steps. And you'll see from the diagram above here is that AC and CB are drawn to be perpendicular. So from a given point to a line, the definition of distance is that it's the perpendicular length. So that's what we would do here, is that we would draw AC, so it's perpendicular to AB, and the same thing with draw CB, perpendicular to BC. So very quickly, hopefully you can, if you know that you have a bisector, then angle 1 and 2 are going to be congruent to one another. And we can prove that these two triangles are congruent by AAS because PC is congruent to PC. If that's true, then we know that AC is congruent to CB, and therefore they are equal to one another. So again, that equidistant concept is going to come through here. The converse of the angle bisector theorem states that we're trying to prove that PC is the angle bisector. If we know that AC and CB are equal lengths, so the way in which we draw these is so we draw them so that they're perpendicular, we end up having that these two triangles are congruent by, what would we say? What would be the reason we could say that these two triangles are congruent? Hopefully you said HL. Therefore, we would say that the two angles would be congruent to one another. By angle addition postulate, we know that the two angles equal angle APB, and therefore PC is indeed the angle bisector. So again, these are referred to as a locus of points because they meet the same condition. What I'd like you to do now is put the video on pause and go through examples 3 through 6, please. So taking a look here, based upon the given information, we do know that we're going to end up having that BC is equal to DC by the angle bisector theorem. So we're going to have an answer of 7.2. Taking a look at example 4. Hopefully you have finished these problems. We know that by the converse of the angle bisector theorem, we can say that the two angles are equal to one another, and therefore the measure of, I'll get through this very quickly. A is going to equal 6. And then therefore the measures of the angle is 38. In example 5, based upon the given information, I hope you've been able to figure out what the answer is. We know that these two angles equal the measure of angle XYZ by the angle bisector theorem. We can do a substitution, and we know that the measure of the angle is going to be 126. So taking a look at this application problem here, we have the angles are the same length and they're equidistant. So in terms of how do we know? So by the converse of the perpendicular bisector theorem, we know that B is the midpoint. So we know we have a perpendicular bisector, so we know that they are going to be equidistant from one another. The next example is to find the equation of a perpendicular bisector on a coordinate plane. So there are several steps that you want to go through. The first step is maybe to graph it, get a sense of what the graph of the segment looks like. And so the next thing that I want to do is I would want to find the midpoint of line segment CD. Again, using the midpoint formula, we know that the midpoint is 8, -2. The next thing that we will want to do is we want to find the slope of segment CD. So everybody go ahead and find the slope. So the slope of CD is 3/2. So the slope of the perpendicular line would be the opposite reciprocal. And now we put the information together. We use the midpoint that we found and the new slope of the perpendicular bisector, and we keep it in point slope form, and that's our graph. So I hope you were able to fully get all the notes written down. Don't be afraid to go back and review.